Right, Brian, it is showtime, as you just mentioned. Oopsie daisy, right? Like, can you believe it? Episode 27 of the Trino Community Broadcast already again. Of course, the best SQL query engine in the whole wide world. And today we are broadcasting from around the world. Myself, I put myself into Europe this time. I was broadcasting here from Salzburg, Austria. Our guest Paul is broadcasting from New York, and Brian, as usual, sitting in good old Chicago, bringing us all the news of the world in Trino land. So what's going on today, Brian?
Well, apparently our intro song like sped up there for a second. Did you guys hear that, or was that just my side?
It sounded like the same thing, and I was like going with it again as usual.
Yeah.
Right?
Yeah, no, I guess it was on my side then, because I actually got like a sped up version. It's weird. Yeah, so today we have on Paul from Treeverse, and he's going to be talking to us a little bit about this really interesting product called LakeFS. So welcome, Paul. Thanks for joining us today on the show. Tell us a little bit about what you do and what a little bit about Treeverse without going into the full detail.
Yeah, sure. Hey, Brian and Manfred, thanks for having me. Really exciting to be here. I'm Paul. I'm a developer advocate at Treeverse, which is a company that's developing an open source project called LakeFS. At a very high level, we provide Git, like a Git for data product that lets you version your code and have Git inspired workflows for your data pipelines.
Yeah, we're going to dive a lot more into that for the rest of the show, and it's a really cool kind of like a newish kind of concept that I think I heard the and I'm always going to forget her name, Eileen or Inat. I'm like, I knew I was going to screw it up. But Inat like talked really well about this on another podcast, Open Source Data with Sam Ramji, and like really cool story that kind of led up to this. I don't know if you know this, like can tell the story as well, Paul, but maybe when we get to the concept of the week, I'd like to dive into that a little bit more, because it's kind of one of these interesting things that it's a newer type of concept in terms of thinking about Git on your data, right? And so that's definitely something I'm really excited to talk about, and something that's really exciting that could save a lot of pain for a lot of engineers and late nights and all that kind of fun jazz, right? So before we hop into all that, let's go right ahead and do a little bit of the ad for the show.
I'm Colleen Tarto. I am the Director of Engineering on Starburst Galaxy.
What is it actually offering? So, I mean, I think this kind of like builds on some of the open source Trino stuff, but is it doing a lot more? What kind of pains is it solving? Could you kind of give us a little bit of insight on what actual pain this is going to be alleviating?
Yeah, absolutely. And so to think about that, I always like to go back and think about what's the difference between Starburst Enterprise and Trino, right? And so I always like to think of Starburst Enterprise as the cool older sibling to Trino. It's a little bit more mature, a little cooler. It's got a car. It's got some cool stuff going on, leather jacket, And Trino is awesome in its own right, don't get me wrong, but Starburst Enterprise is just better and a bit more grown up. And specifically what that means to me is that with Enterprise, you get more. You get more functionality, faster performance, more connectors, more security, better management, better integration into the ecosystem of tools that you already use today, data governance, integration, et cetera, et cetera. But what really speaks volumes to me is that when you use Starburst Enterprise, you get Starburst, right? You get best-in-class support from the folks who work for us, and they know Trino best because they created Trino, and they're continuing to contribute to Trino. But Starburst Galaxy takes that to a whole nother level, right? So one of the pain points is installing, managing, maintaining, monitoring Starburst Enterprise. And so Starburst Galaxy alleviates all of that, right? So it's a fully managed service. It's Starburst Enterprise as a managed service and more.
And one last question, is there going to be any free offerings coming up anytime soon? Is that on the road?
Absolutely. We're building out, we've got a free trial So if you're interested, absolutely reach out to us. We are very excited about it. And then we're talking about sort of a free tier. So like being able to just play around with it in your own environment and see what's what.
We'll keep you all up to date on when you can start to play around with Galaxy and Trino for free for just a little bit and get to know this incredible service called Starburst Galaxy. Thank you so much, Colleen.
Thank you.
All right. So Manfred, we kind of left off doing a little preview for 362, but we actually, I think, covered most of what was going on, but just wanted to give you a quick opportunity to kind of, go back over anything we might have missed and maybe give us a little sneaky peek of 363.
Yeah, let's be sneaky. Last time, it really our prediction that the release is going to come up shortly after the broadcast was live, because guess what? It was released literally a day or two after. It's 10 days ago now, so the 20th of September when we got 362 out. And the changes we discussed then were basically the changes that made it in. So list aggregation function and a whole bunch of things in various connectors. And the cool thing is, since then, if you look at the Git commit history and the commits in the code base, there's like 4 pages of changes already. So 363 is shaping up to be a pretty interesting one already as well. So the engineers are not resting. The hackers are going on it with more and more speed, more and more contribution. So I'm loving how it's going on. Specifically, I'm noticing that a whole bunch of stuff is making it into the MinIO kind of support and the testing of that. So for those of you that use alternative S3 compatible object storage with the Hive connector, I think you'll find out that it's going to improve even more, even though it's working very well. So that's cool. Iceberg connector is always busy. And then also I noticed, again, as in the 362 release, a whole bunch of stuff is happening on the BigQuery connector. So there's really some significant effort going into BigQuery. So this is really showing up to be a first-class citizen connector in every regard. So it's pretty awesome.
Yeah, it's really neat. I've heard a lot of chatter recently about BigQuery because it's like, everybody's looking for maybe an alternative to like Snowflake as kind of the the ETL kind of traditional data warehouse engine. So some people are totally all on board with Snowflake. Others kind of want the alternatives, and so I think that for the people that are in the let's get away from Snowflake camp, BigQuery has become a popular secondary option, I think, for those, and even people that kind of maybe have particular uses. I think there's a lot of like machine learning kind of stuff built into.
Yeah, there's all sorts of additional tooling, so it's pretty cool. Which by the way gets me, which also interesting. All the things we talked about are all big object storage, data lake, data mesh, data warehousey kind of like technologies, which really are showing the strength of Trino. And that gets me to Paul's topic, because I have no clue about LakeFS, but I use Git all the time. So I'm super curious on what this will mean. Don't get me wrong, I love Git. I use it every day, but it's also tricky. So let's find out a bit more about LakeFS and how it relates to Git and object storage and whatever. Tell me more, teach me about this.
Well, let's go to the concept of the week. Sorry, didn't mean to cut you off there, Paul, but please tell us more about LakeFS and Git on object storage.
Of course. So essentially, object stores are really popular for data and analytics type of work. So there's some estimates that the amount of data for this purpose, like being stored in your S3, Azure Blob, Google Cloud Storage, MinIO, is doubling each year. There's, it's no secret there's a lot of data being generated, and people are trying to make use of it.
Yeah.
And the experience of using object stores, as they're meant to store data, but they aren't necessarily meant for all the workflows that they support related to data and analytics work.
Yeah.
So what we realized, having used object stores for a number of years, is that if we could extend them with additional operations, then they could be better. And conveniently, we found, or we had the realization that if you could take a lot of the workflows that are used for source code management, that deploy applications and let people collaborate in isolated branches, if you could apply those to working with data over object stores, then it makes your life a lot easier, and some processes simpler, and they can take less time and be more efficient. So that's what LakeFS is.
What's a typical kind of use case that maybe we want, like, I'm running into some sort of problem where I would need this. So could you kind of give me like either a use case or like, I think maybe even motivating this, like what kind of problem would be the kind of primary driver that people would use LakeFS for, to, and particularly this whole Git workflow, because I think that's kind of the foreign part of, like, okay, I get it for source control, but like my data, like I'm not going to be looking at diffs over, unless they're text files, right? But typically we're dealing with like binary blobs, right? So it's like some people might get a little confused by that. What's your take on in terms of like where this really shines?
Yeah, so there's it's a great question. There's three use cases that I like to point to. One is fixing and understanding the root cause of data errors. So you have, it happens like every day. There'll be an error with data, or data's sort of missing or just wrong.
Yeah.
And, it's not always the simplest process to identify the bad records, or at the very least, just return the data to a previous correct state.
Mm-hmm.
You could be, looking for like individual files, or running delete queries with certain filters, and kind of mess things up more. So one thing that having version data lets you do is, again, similar to Git, is let's restore the data to a previous commit, and run a revert command to like in one line, and instantly bring it back to a better point in time.
Now there's a similar kind of momentum going with that particular use case in the table format space, right? So like you have Iceberg, Hootie, and Delta Lake. Is this kind of this overlapping with any of those use cases, or are they the same thing, or is it different? Could you kind of dive into that a little bit? Because I think a lot of our people, we're big Iceberg fans typically, and so I think that's kind of, that triggers the association there in my mind with Iceberg and what they're offering as well.
Yeah, it's there's some overlap in some ways. I think they're complementary, and I'd say we're still figuring out the workflows around like a real modern data lake that is effectively using both types of technologies. Yeah. So a crucial distinction is that with LakeFS, we have a concept of a repository, which should be, again, familiar. And the typical architecture we do recommend is to have essentially one giant repository with all your tables. And so compared to Iceberg, you can have 50 Iceberg tables in one LakeFS repository. And it kind of gives you, one way you can think of it is gives you like another lever instead of maybe rolling back 50 different Iceberg tables. Now you have this sort of higher level view or like layer where you can roll back all tables in a consistent way to a specific LakeFS commit.
I think, go ahead, Manfred.
So when you say, so this like the analogy to Git is very interesting because like, a data lake is basically a bunch of files. They're binary files, but they're a bunch of files. They happen to be stored in the cloud somewhere. Git as a version control system is very much all about like obviously Linux Torvalds wrote it initially, and he's very much a file system guy. So that works very well together. But in the Git world, at least, there was a bit of a changeover to, like, there's a certain threshold of pain involved once a repository gets very big. But now on the LakeFS side, you are talking about massive amounts of data. So how does that chime in when you say you can have just one repo? I'm like scratching my head because in the past I've like mucked around with like Android, for example, and the source code for Android. And it's super painful when you have like a very large Git repository, and then you have tools of like having to deal with multiple Git repositories. So how does that work with LakeFS? Do you like really one repository, and what's in the repository? Maybe you can explain a bit.
Yeah, so I'm not sure if this was the main idea of your question, but one I think important component or like design principle of LakeFS is that we really went all in and designed it to be scalable. The idea is to bring that Git-like versioning to where it couldn't be brought before, and it wasn't like technically impossible. It was just that no one really designed.
No one even attempted it, right?
No one attempted to. So we're proud of being innovative in that way, and it does kind of it does take people a little bit of time to accept the fact that it's possible. And Brian alluded earlier to Oz's and Inat's sort of origin story coming from.
Yeah, let's hear about that a little bit.
SimilarWeb. Yeah, I recommend going to the podcast he mentioned for probably a much more detailed version. But
I'll link it in the show notes for the people listening in.
Yeah, but at SimilarWeb, which is the company they had the idea of LakeFS for and left to start it, they were working with I don't know if it's one of the largest data lakes, but it's an analytics company that provides insights into, from my understanding, a lot of like Amazon product data, and they're just ingesting tons of data in that way, and it's petabyte scale, and LakeFS was designed to handle data lakes of that scale.
Yeah, very cool.
That sounds very aggressive and amazing to me. So it should be cool to find out more.
So
okay, finish.
Sorry, just another thread to thinking back to the original question, but so essentially LakeFS is it keeps track of metadata about your data. One of the fundamental concepts is the commit, which a commit is taken over a repository. So it's like a snapshot of your data at that time. And behind the scenes, the LakeFS side, it's very efficiently keeping track of which files are contained in each commit, and it's as much as possible pointer based, so there's no data duplication, and in that way you can hop in time between commits across your whole repository.
Yeah, and I think like once you kind of associate it with Git, it's the first like glance at it when you're just changing out the actual content that you're sourcing, right? Or that you're essentially like, doing all of this atomic snapshotting with, it kind of does like, gives you a second guess. But then like after you think about it a while, I mean, especially now with table formats kind of taking one more granular view of snapshotting, now you guys are taking this kind of more holistic repo approach. And that is very analogous to kind of the way that we use like Git, and we're sourcing source code, right? it's just as like, if you think about data in terms of like value, like, the same way that we have source code, any time that we're spending writing that source code, making sure that it aligns well with other things, like, and it's versioned properly and that we can understand it, going back, that's the same needs are there for data that there are for like source code, right? And so I think the analogy was actually kind of very interesting and beautiful that you all put that that you're using Git, because it makes a lot of sense. Data is super valuable. Data takes a lot of time to get and make correct, and make sure that if you do kind of like, let's say, go off into like a kind of feature thing, and then you kind of get a chance to play around and then possibly fail, and not screw anything up, then you're not affecting anything that's going on in the main branch, right? And these same concerns that exist for writing good source code is also about like generating and sourcing good data to analyze. So it's a very cool analogy, and it at first when you think, oh, well, why are you making that analogy, but then it just, like, as you just ponder on it for a bit, it just makes perfect sense. So it's very cool. And I may have alluded to, there's a couple other use cases you were going to get into, and I think I kind of trailed off on for you there.
Yeah, I wasn't sure if I should continue that thread, but I agree that was a great teaser for another important use case, which is branching, and ultimately to help create a realistic and complete development environment for your data, where you can run different tests, particularly run tests in parallel, in a more thoughtless and elegant way than maybe you would just over object storage itself. And ultimately, for larger teams, it helps you essentially collaborate better in terms of being more independent. If I write this data here, or I overwrite this data set, maybe it won't ruin someone else's model or experiment, or maybe it would. And it's easier when you can take the another Git inspired command that we expose is branching. So you create a branch of your, again, repository, and it doesn't copy the data until essentially it has to, if you make a change and write it back.
So let me get this straight. So you're saying, similar to how you can work with Git, have your separate clone of the repository, create a branch in there, and work independently without being messed up by other people working on it, you can do the same now with LakeFS on a data lake?
Yes.
Wow,
perfectly said.
That's interesting.
So like
I can think of a lot of use cases for that. That's
cool.
cool.
For sure. But the question kind of comes to me is like, so is standard practice, by like when you are consulting and you're helping out any of your customers that are using, I don't know is it called Treeverse, or are you guys just adding support to TreeFS? Is there an enterprise version?
We're solely open source project at the moment of LakeFS.
Okay, so you're consulting for kind of LakeFS, if that's not the, correct me if I'm wrong, but then you essentially, if somebody's using LakeFS and you're kind of telling them how to do this, would you advise then like to basically test and prod? If you're, but obviously not on that branch, right? You have branches now. You could test with the prod data and essentially branch off into that. Like, is that what you advise to do, or is there any repercussions of like, of still doing that? Is there like resource intense pieces that you still have to consider? Because like at the end of the day, they have one cluster, or like a production cluster that can't go down. So like, but for the most part, like what's in practice, do you recommend doing some testing, or how do you like, advise people around those types of scenarios where you can essentially test and prod kind of?
Yeah, that's a great question. I would say that there are certain scenarios where maybe you don't want to test in prod. You're connecting. If you're running too many experiments, you don't want to hook up your data warehouse or your Trino cluster to run all these tests. But I will say that you have the option to, at least, and that's a useful option that doesn't come as easily without something like LakeFS. So you have the option to. It's definitely useful to, before you, if it's a maybe consumer facing or super important type of data set or process you're running, it's always useful to run it in as realistic an environment before it goes live. So you have the option to do that. What you would say does bring up an important point that is just a struggle for data stacks and environments. Is that like once you have like a prod and dev environment for one tool, and like if that's like versioning that can kind of provide that, you have to mirror those environments across your whole stack. And that can be, not every tool is as easy to install and to support that. So you can run into issues where, you're pointing too many versions of your data now at, like one Metastore or one SQL engine, something like that.
Like, here's a crazy thought. Like, would the goal ever be to like basically have one go now to one environment, and then like you just constantly scale up that environment, and you have LakeFS to branch for your staging and your dev and your testing, and you're just working off like one, like that. I don't know. Has that ever been a thought that's crossed your mind? And is that something you think would even be like on a conceivable roadmap? Because you guys are kind of thinking out of the box. So that would be kind of a crazy, like, hey, we don't have to have staging or all these different environments now that are fake copies of the real thing, and they don't really do a good job at mimicking a lot. Like, we had so many times where when we got up to the real scale, it just like tumbled over, like whatever thing that maybe we wrote. So like, what if you just had one environment that you just like, you don't have to now maintain a whole bunch of these, and now you're just branching and doing a whole bunch of stuff, like where you got a stage branch, and you have a dev branch, and you have everybody's own has their own branch in this one environment, and you just scale up the resources.
I think that's really getting towards the vision we have, or essentially what's possible. Data is often the blocker towards achieving that at the larger scales. It's just not really feasible to copy a data set that's has millions or billions of files and is petabytes and up. It's it has a lot of gravity, and it can be expensive to run the full test essentially. But it definitely is nice. I think LakeFS makes the data, even very large data, as lightweight as possible to do things like that. Let me just get a quick copy of it and do something here. It's definitely a step in the right direction.
Yeah, it was really cool. So that was two. Well, you said there were three. Can you pull up the third kind of?
Yeah. So we talked about essentially fixing and reproducing production errors. We talked about having this nice instantly available realistic dev environment, and a third area, like in a typical data workflow lifecycle that we really feel LakeFS contributes, is what we call deploying data. And the Git operation that shines here that LakeFS exposes is merging. So you can merge data from one branch to another. If you create a branch, run an experiment, see which one is performing better. If it's maybe like a metrics differences, or even like a machine learning model taking inputs from it. You can then you can, if it was like a experiment branch, you can then, and you like that data better, you can merge it into the production main branch. And this is something that it's an improvement on the way a lot of data lakes work today, where data is just added into production, into like the main data set, and then maybe like testing occurs after. Here, across multiple tables, again, you can merge data from one branch into another and expose it atomically. And additionally, this does give rise to an opportunity to run data quality checks before the merge. So we allow you to define those tests as hooks, as we call them, and fail the merge from succeeding if the test fails, and of course it will succeed if it passes. So
another big part of the strategy, it sounds like, is like automation 100%, like kind of a CI/CD kind of bring out different ways rather than just testing software, really bring in the testing the data element in as well.
Yep.
Cool.
100%.
So a question about that merging then. When you, like earlier on, you talked about how LakeFS manages and operates on the metadata about the data lake. But then now when you talk about merging, you're talking about the actual data being affected or somehow. So where's the border there between what LakeFS does and doesn't do? Say like deleting data or like modifying bulk data and stuff like that. Where is it just a branch, and where are the actual files? Like in this image, you have LakeFS sort of wrapping around S3 and MinIO and others. Where is the blurry lines there? I'm not sure I fully understand how it works internally, obviously, architecturally.
Yeah, no, great question. So wrapping around is actually a phrase we use to describe how it works with the object store. For better or worse, sometimes people are afraid by that a little bit. But yeah, so I mean, LakeFS generates its own metadata about your data to understand primarily which objects or files are contained in each commit, and then commits belong to a branch. And if you're merging one branch into another, it has pointers to the actual data objects, and knows, and essentially is keeping track of which ones should be available on a branch or a commit. But the data is still stored in your object storage. It is, I guess you could say, LakeFS, sort of reaching in and yeah. But
so where does LakeFS store its metadata then? Like I know, like most of these, like S3 or MinIO, they all use the Hive meta store for the metadata about the object store. Is LakeFS sitting in the Hive meta store or storing it there, or does it have its own storage system? Hopefully, maybe so it can work with the multiple meta stores or whatever. Like where's that stuff stored? Is there another layer somewhere that I can't see on the image at least?
Yep. So LakeFS runs as a binary service that you can run on Kubernetes or ECS or any type of service, and it uses a combination at the moment of an internal Postgres database and the object store itself, mostly the object store, to keep track of the data. It is one of our sort of longer term projects to eventually remove the Postgres dependency. It's just it'll be a fairly significant refactor internally that we're going to complete. But yeah.
So it's a bit like Git, where all the Git metadata is also stored in the file system, just happens to be in a hidden directory in like .git and all the files in there.
Yeah.
Yep.
In your case, it just like all the metadata is in files that are also the object store, but they're just metadata. Is that right?
Yep.
Oh.
Yeah, it's very similar to I'm more familiar actually with Delta Lake than Iceberg, but I assume they're very similar in the way, like, you can see the Delta log next to the data in your table.
Yep.
Yeah, that's similar. Okay, that's interesting. Very cool.
Very, very cool.
It's amazing how far that analogy then that basically goes. That's cool.
Yeah. Yeah, it is a very good. I stand on it again. It's a very solid analogy to use. So let's see if I had a couple features kind of written down here and some of these use cases, but anything else you wanted to kind of cover before I dive into a little bit of a demo to kind of maybe solidify some of the things that we're talking about here, or anything you wanted to kind of feel free to like talk about what you all do at Treeverse. Like what is actually, that's a question right there. What do you all do at Treeverse, and and how does Treeverse relate to LakeFS?
Yeah, so it's there isn't too much distinction, I guess, to make there. It's pretty common. A couple other examples are like Superconductive around Great Expectations is another project, and what used to be called Fishtown Analytics around DBT. Just more like a formal company entity around the open source project.
Got it.
So we actually are starting to be a little more active in sort of consulting with some of our users, but what we're mainly doing is building a community, trying to help the data community understand and use LakeFS to help them with whatever data work they're doing. So me personally, as the advocate, producing content and speaking, but otherwise we're developing the project. We're responding to user requests. We're giving help in our help and support in our Slack.
Enid, your CEO, she like a physicist or something like that, or like some really crazy PhD title. And is that like, that's how she has her background in kind of data? It's kind of an interesting story on how she got into the whole data biz, I think. But do you know what she does, or offhand, or?
Yeah, I mean, she was an algorithms engineer.
Okay.
I think her first experience. I actually don't know too much of like specifically like what she was doing and what types of languages and environments she was working in.
Gotcha.
That is
so maybe in the spirit of getting towards the demo that Brian shows, can you give us a bit of an idea, Paul? What does it take to get to use LakeFS? So you have your data lake on whatever technology it is even compatible with, and then what does it take to get into it?
Yeah, so you have your data in an object store, and you can once you have LakeFS installed again on as a service on like Kubernetes or on a any sort of instance, so you can import your existing data. You can see our documentation way to do that, or just write new data to the repository. And the important point here is that we maintain API compatibility with S3. So any tool or technology that knows how to read or write from S3 can pretty seamlessly start reading and writing from LakeFS by it's common. It's the case in Trino where you can set the S3 endpoint for the tech for the
for if you have a Hive connector that queries and is set up, you point it as an S3 URL. Now you're pointing at a LakeFS URL. Essentially,
you point it to your LakeFS server URL, and it essentially works seamlessly behind the scenes.
Yeah. And you could also do the same with Iceberg as well. I didn't actually have that part in the demo, but I'm pretty sure it's like, the same swap out that you would do for, running it on MinIO. Anything that you can run on MinIO or S3, it's just like a swap for the keys that you're using and the endpoint. So
cool. Well, maybe you want to show us, Brian?
I will. Let's do the demo of the week. There was too many screens to click through. I couldn't get my screen up fast enough, but here we are. Okay. So we are going to be covering how to run Trino on LakeFS today. I have just a couple. I'm going to actually put a lot more of the kind of background on how to run this after the show. I didn't get really too much of a chance to get that, but for the most part, as per most of these demos that we have in here, we go to the Trino getting started repo that I have going on here. We now have a little spot. Is my screen showing correctly?
Yeah, looking perfectly. We see the Trino getting started repository and GitHub, where all your hackery for all the Trino Community Broadcast can be found, and you're looking at the LakeFS folder now. Awesome. Yeah,
we got a new LakeFS folder. So this is kind of pretty much a copy of what I did for the Hive and Iceberg folders, but I just mixed them into one. I haven't played around with Iceberg, so I'm not going to do that live on the show today, but I am going to toy around with Hive. So you go into that one, and basically it's typical setup, Docker Compose on the bottom, and then all the configuration files. But as we were kind of mentioning, I wanted to just jump into this real fast. In terms of the configuration. So you have a Hive or an Iceberg setting that you have here. And the big difference that we're going to see here is we're going to have, instead of the endpoint here, let me just bring up for those that haven't seen this before. Let's go to the MinIO one.
Brian is looking at catalog properties files for querying MinIO Hive.
Yep.
And we're looking at the connection URL, right?
Yeah, I highly recommend if you go to the Trino getting started repo, and then just go into the we're comparing the Hive Trino and MinIO project with the LakeFS one. So if we hop into the configuration files and look, not configuration files, I meant to go into the Etsy folder that is going to be, and catalog folder that is going to be where we store our catalogs from MinIO, from Hive, and then we'll compare that. So this is the MinIO one, and you can see the endpoint here for MinIO is just whatever URL I have set to directly talk to my MinIO cluster. So that's MinIO, and then the port is 9000. I made my access keys for MinIO super simple, which brings up a funny story here I'll talk about in a second. MinIO and MinIO 123 are my access key and my secret key for MinIO, right? If we compare that to what we have in the Hive properties for LakeFS, all we're really doing here is changing out the endpoint. So we have the LakeFS, which is the thing I'm using internally for Docker as the URL. And then instead of port 9000, I'm doing port 8000. And then I just update my access key and my secret key. Now, I usually make these access key, secret key things like really dumb and simple, so that you when you're playing around with it. I did that again when I was putting this demo together and ran into a bit of an issue that luckily the folks at on the Slack channel at LakeFS Slack channel were able to help me out with. They actually run the algorithm to verify that these access keys and secret keys are correct. And so they have a standard example set of access and secret keys to use. So that's what I'm using here. And that was causing me about an hour to an hour and a half of delay on getting this thing done. So anyways, if you are wanting to play around with this and you wanted to ever change the access or secret keys, don't. So that's just a little aside. So let's hop right into the good stuff. We look here. we can, let me just pull up the Docker dashboard about what's running here. So we have a couple images running here, and we actually have two that have stopped. So these are just actually these little helper containers. So we can actually just get rid of those. When we started up all of the Docker containers, those two just start up. They initialize some stuff in MinIO and LakeFS, and then they just exit. So then the rest of these are running. We have, the Trino coordinator, we have MinIO, and then let me see and then we have MariaDB, Hive Metastore. If you've ever played around with some of the demos that I've had before, these are the four that we always have. The two new containers that we have for LakeFS is, of course, one that's running LakeFS. And then again, what kind of, Paul, you were alluding to before, is that you're all using Postgres to kind of store a lot of the metadata about what LakeFS is storing about these Git operations going on. So those are all the containers that we have running now. So first thing we can do, let's just go, if we look at LakeFS, they have a nice little slick user interface at port 8000. So if I let me pull this open and go to, actually, I think I already have it open here on this tab. So we have, port 8000 open, and now I'm greeted with a login and a for access key and secret access key. So as we kind of mentioned before, let's not make the issue of making that a simple one. We actually have to go in and get the real, or some fake real key, some key that actually passes the check.
Security check, huh?
The check.
Yeah, to my knowledge, I don't know where it happens, but it's not purely like LakeFS trying to prevent simple usernames and passwords. At some point, like AWS or S3 has a check like that the key is realistic.
Got it. Okay. Yeah, it's interesting that, like, so this. What's weird is that, like, if MinIO doesn't ever run into that for some reason, but I'm guessing you guys are using a particular library that does, like, enforce that, I guess.
Yeah, I can ask to find out specifically where that happens.
Yeah, that we're added an hour and a half to my demo making.
So in this place here, we see the LakeFS user interface with a cool mascot that I can't see what it is. Looks a little bit like.
Yeah, can you tell us about that mascot? Yeah, he's really cute.
Yeah, it's a rare type of lake type animal. It's called an axolotl.
Oh, it is? Okay, cool.
Yeah.
What is that here? How do you spell that?
AXO.
It's like an amphibian, but it's like, looks like very old and has these like external.
LOT.
There we go.
Yeah, there you go.
Oh, look at that guy. All right. Well, we'll have to add that. I mean, so it's spelled AXOLOTL if you want to search that right now if you're listening in. So yeah, a really cute little guy. So yeah, it looks just like him too. The little image that you have. So
so that UI with the mascot runs on one Docker container in this environment here. Question though, when you scale that larger, is it also a cluster of machines running basically similar to Trino, or how does that work?
If you scale it,
like if LakeFS is running on a lot of data, is there still like there's the one LakeFS server, or is there like a cluster of them or something?
Yeah.
Or how much traffic do they even get? I don't know.
You can scale it between different workers. Okay. I actually haven't tried that personally, but it is scalable in that way.
Okay, cool.
But is it not typically like heavy need or anything like that? It just depends. Like usually just a production kind of thing where you'll run into that.
Yeah, typically for most of our users' workloads, they can be handled by one instance with just the metadata that it's keeping track of.
Got it.
But yeah, I mean for resiliency and redundancy, you can scale it to multiple workers.
Very cool.
Okay, very nice.
So, so what we did, one of those little helper containers actually created for us, and you can see this too in the, if we go back to the LakeFS Docker Compose thing right here, you can see the basic command that was done by one of the LakeFS setup. It logs in and runs the setup keys. That basically sets the setup keys and then creates this example repo. So right when we first log in, we're greeted with an already existing example repo by that command that's run. So nothing's in here yet, but this is where we can kind of get started. Now we're from the Trino side. Remember, we're pointing already to this, and so we should now be able to, once we kind of run all our stuff on Trino, we should be able to now basically be able to start creating stuff. So what you're going to do for the schema now, when you're like, let's say you're creating a schema and creating the tables to address them, you're going to have like a little bit of a namespace that you'll need to use. So the namespace is going to be, you know, the protocol, which is going to be S3 or S3A, and then : / Then you're going to have the name of that repository. And then so in this case, we called it example. And then you'd have another / and that's going to be the name of the branch. So by default, we had this set in the script that ran. By default, we have that set to main, just like you would in GitHub or something like that. And so from that point down, from that namespace, that example, / branch name, then you have another /, and that's where the same way that you would in MinIO, you would actually be placing some sort of like bucket namespace. And so in this case, I'm calling it tiny because we're pulling from the tiny schema for the TPCH data. So let's go ahead and create that schema. Create schema minio.tiny with the location that I just kind of specified. Go ahead and run that. And it's going to take it just a schmeckend.
So this just runs right in the Beaver, in this case here, running SQL statement, goes via LakeFS into the object storage.
Yep. So this from dbeaver to Trino. Trino now is talking to LakeFS. LakeFS is then talking to MinIO. So yes, it's kind of that thin layer in between. So
it captures the metadata and knows what's going on.
Exactly. Or at least that's what it seems like. Correct us if we're wrong, Paul. You're the expert here.
Yeah. No, it is kind of a stack of technologies working here. But
nice. So oh, go ahead.
I was just gonna say virtual high five, Brian. We're getting good at this guessing game.
Yeah, I know. We're just gonna start agreeing and saying things are the way they are, and if we say it confidently enough, then people are gonna believe us. So next up, we'll go ahead and we're gonna create the customer and orders table, and in this this is again going customer and orders from that TPCH generated data set. So we'll create the table. It's going to use a CTAS statement, which is create table as minio.tiny.customer. And we're going to do that in the orc format. And again, now at the external location, we're going to say all that previous namespace we just did for the schema, but then we're going to add the name of that table. So it's going to be a customer in this case. We'll go ahead and run that. And we should see pop up down here, 1,500 rows get inserted. While that's running, I'm going to go pull up MinIO, because then we can actually take a look at what's going on the MinIO side. And MinIO has it's already pre-logged in because I already had the dumb browser in there in their example. Is this right, though? Hold on. I think we should be seeing okay, that's been created now. We should now see, I thought we should see oh, no. This is my bad. So from MinIO, we don't see the logical folders. Is that right, Paul?
Yeah,
we see that is correct. Okay, so now we're in LakeFS. We see these kind of blob object files, but in MinIO, but we don't see that in LakeFS. In LakeFS, we refresh. Now we're going to see that logical folder structure, tiny, and then under that we're going to see our folder for the table. So let's go ahead and create the orders table now. We'll run that. Same CTAS thing, but now we're just essentially just talking orders table instead. Great. And that was 15,000 rows that got inserted. So if we go back to LakeFS, boom, we now have orders table that has all this binary blob data sitting in there. Cool. So, okay, from there, I want to run a quick query. And this is going to be just a query against, a join that happens on customer and orders. So I'm going to go run that query real fast. And this is going from min.io tiny customer, right? And again, just to remind everybody, like where the min.io.tiny schema is pointing to a specific branch in LakeFS. So we pointed that to the main branch. We like, so that comes out with some data that we like. We're really happy with where it is. Why don't we take a snapshot? Why don't we take this, do a quick commit? So I'm going to do this through the UI because I think the UI is super slick. And I don't feel like you see me doing enough CLI stuff with the other stuff. And I didn't feel like, there is a CLI, a whole list of CLI stuff in the references that you can go through. But, I always like going through the UI things because, again, it's just so much more intuitive and nicer to look at. So if we go click here, we see uncommitted changes. And this is really cool. The layout looks very similar to what you would see on
GitHub UI, yeah.
Yeah, it's a GitHub UI right there. So we see three lines here: the tiny folder that got added, the nested folders that now have these blob files of that essentially hold our table data. And so I want to, I'm at a point where I want to commit these changes. Let's go ahead and click commit. We're going to put a little message saying, I'm just going to say init commit for customer orders and commit those. And I guess I can add a metadata field. What kind of things would I expect to be putting here? Is that like a tag in AWS, Paul, or what does that do there?
Yeah, it's pretty free form. You could put like like Trino version or added by and then your name.
Got it.
Anything.
Very cool. Okay, so now we commit those changes and cool. So we have and these are this is again showing kind of a lineage view of the commits that have happened on branch main. Now let's go ahead and actually branch this out. So, we have main at a pretty good state. I want to do a little bit of that experimentation stuff we were talking about before. So I'm going to click on create branch here, and I'm going to branch from the main branch, and I'm going to call this one sandbox. I have sandbox, and as you can see, the commit hash here, just like Git, it looks the same. You have some SHA that's going to tell you, like where you're at in the lineage. So now I need to create on the Trino side. The data is kind of logically copied over. But I don't have any schema that's going to represent the same thing. So I need to create a schema that's going to point to that branch now. So the same way we had the namespace before, it's S3 A : //, and then we're still dealing with the example repository that hasn't changed. But what we're going to want to change now on the second point is we're pointing to a new branch. So we're going to update our schema to point to the sandbox branch and then still call the schema tiny at this point. So run that. We got schema set up now, and now we want to actually create our new tables. Now, like you said, Paul, right? Like we don't have to actually copy any data here. So we don't have to run a CTAS like we did before. But we still need to create the table. We still need the schema that's going to point to that correct location. So what I recommend if you're doing this on Trino side, you do a show create table. And so if you run that, you'll get the create table statement here. And all you need to do is change. So this is showing the create table on the main branch on min.io.tiny. So you're going to want to update the name of the schema. So in this case, we're going to call it tiny_sandbox for the schema name. And you're going to want to update again the external location that's pointing to the sandbox instead. So let's go ahead and I have the pre-can statement. Again, this will be in the show notes as well if you want to run these as yourself and play around with it. But we'll run that table now. And so this, instead of doing a CTAS, this is just a regular create table that's just putting the same metadata that was in the other table there, but it's just pointing to the correct location now. And so now I'm going to do the same for orders. So I do a show create table for orders. I update the branch that it's pointing to Sandbox, and make sure that I'm pointing to the correct schema for that table. And table, I was playing around with transactional tables here. Ignore me here. So I was trying to get some cooler part of this thing. So we do a create table without transactional for now. Hopefully we can get some cool delete functionality coming on later. And let me I want to do a quick scan. Did that actually work? Let's look at the customer table and just scan the top 10. And sure enough, this is looking at the branched off Sandbox. Again, we haven't added anything to that branch. It's still pointing to the same location as main, but now we have this logical separation of where we are, or of where we're going to commit to. So if we add something, we're not going to affect anything on the main branch. We're going to affect it on the Sandbox branch. So I can actually still, if I run the exact same query I ran before with the Sandbox, I can get the exact same results that I did before. Again, so it's the same thing. And here is where I was wanting to do some cool drop table stuff. But what I think I'm going to do instead, and this is going to be that live element that I didn't get enough time to plan for. But why don't we actually do a create table from line item? And so bear with me. This is going to be super, super live and super raw. But we're going to do a create table as, and we're going to do it against the tiny Sandbox. Let's go ahead and do that.
So your plan is basically to insert another, a third table into one branch and see if it shows up in one branch and not the other. Is that right?
That's correct. So that's the goal we're going for here. So we needed to change, again, the schema to tiny_Sandbox. And we want to make sure that the external location is pointing to the Sandbox location. So we update that to Sandbox location. Now we got to update the table names that I just copied. So we need line item. I think it's just all one word, right, Manfred?
Yeah, it is one word.
Okay. And that should be good. So we can create this now Sandbox line item. And this is adding some different change there. Cool. And so now I should be able to actually query out min.io tiny Sandbox line item from the Sandbox one. So actually, let's go ahead and query that out. And then if I copy this and I actually point to main, which is min.io.tiny without the _Sandbox, let me see if it should fail. Let's see the fail. Yeah, we failed. Does not So
it looks like it's working.
Yeah. So if I'm now made this change to Sandbox, if I go into Tiny, I see three locations here, right? I see these three subfolders that are representing my tables. If I come back to the example repository again, I go back again into that tiny schema, and then I go. Sorry, this is under main. I only see the two folders there. So this is where you're getting that really cool isolation. And again, to be very, very clear, the same way that Git doesn't do the copies, the full-on copies of data until it absolutely has to, right? There's too much of a difference, or there's all these. I don't actually know the edge cases. I'm not going to pretend to, but there are some times where you will actually have to copy the data. But for the most part, it's going to be just these little diffs that you're storing, and that is what we've done here. So we have two versions of the data, but we only have basically one copy, and so you're only paying the penalty of storing that data once. So very, very cool stuff here. And I would say that's, do we anything before I hop off this demo? Paul, did you want
I want to see something.
Okay.
Can you go into the min.io browser and see what's happening there?
Yeah, let's do that. Let's see, refresh. So there's this _LakeFS piece here. A lot of metadata stuff that has a whole bunch of
so that's it's like weeding around in the .git directory in a Git repository. We're like, what are all these weird names and files? So
yeah, exactly. And you just have very, very cool. Paul, anything you want me to kind of live demo on the spot or show off anything?
Yeah, no, I thought
merge. How do I have actually didn't get to the merge part. Is that what this compare thing is?
yes. If you go to compare, and I always forget the order, but one of them is going to be sandbox. One of them you can just click on sandbox.
Okay.
If you go back, sorry. Yeah, just click. Yeah.
Oh, cool. Okay. Other way around?
Yeah, other way around.
Okay. Sandbox, and then we need to do main.
Yeah, so it'll show you.
I feel like it would have been. Yeah, I feel like it would be. It was the other way around. Maybe I just needed to click a little refresher. Let me see.
Yeah, I'm trying to think back now
to
like
no. You know what I did? I did a dumb thing.
We don't have it's not committed
yet. This is still new enough for me. So let's commit the changes on Sandbox. This is why live is so much fun. And we're going to say add the line item to Sandbox, and commit that change. And now I believe if we go to compare, let's refresh it.
Well, you have to change one of the branches, but
yeah. Now on compare, switch the left one to
main. Oh, why did it switch both? There we go. Hey, we see the change.
Oh, cool.
So now let's do a merge. And are you sure you'd like to merge? Yes, I would. And this is where you actually break things, right? Is the merge operation. Now we should be able to go from min.io. So min.io tiny line item. Let's see if that works now. Oh, well, no, this shouldn't work now. This should still fail because we haven't created the table. So this will fail. Still does not exist, but the data should be there, right? So if we, like, for instance, if we look over and we see, let's go one more quick time to main. Now we see line item data there, and that's all fine and good. But we need to still create that table like we had before. So let's do a quick.
Like the metadata in the Hive meta store.
Yep, the metadata is not there. The data is there. The metadata is not there. So so let's go quickly malinger this. This is actually coming in from. Let's get rid of this table.
So while you're hacking there, Paul, I noticed before something interesting, and that is there seems to be a command line command that replaces, maybe, I'm guessing, some of the functionality in the UI, something like cuddle or something like that. Did I see that right?
Yes. Yep. Anything you can do in the UI obviously can be a command line command and even more. It is called LakeCTL.
So it's not like in kubectl where it's kubectl, you're calling it CTL.
Yeah.
So all I changed here, I got the create table. I changed back to main because now we're going from sandbox to main. And then I created the tiny thing here. We're creating the metadata. And now, lo and behold, drum roll, data.
We got data. Nice.
All right.
Amazing.
Cool.
All the way merged over. Pretty cool.
Yep.
That's cool.
So we've done some commits on both sides. We did a branch and we did a merge and went through the full cycle there. So very, very exciting stuff. And I think that's pretty neat.
So Brian, what did you do that the demo girls were all with you today?
I don't know. I think it's because I didn't really sleep much last night trying to get this demo together that they were like smiling upon me. So
yeah, that you were. Well done.
So with that, Paul, do you have anything you want to cover before we hop onto the PR of the week?
It was a great demo. I think it gave people a nice idea of different operations available. It's obviously you see that between like the query engine and a tool like LakeFS, there are like these commands to create the table and the new schema. At the moment, LakeFS is sort of mainly tool agnostic in that we kind of work with everything, but don't have like deeper integrations. I could see it definitely in the future that deeper integrations are developed where there is a more seamless interaction between these open source data tools.
Automate some of those things.
Yeah. Very cool.
But it's really cool. It's really cool functionality. Again, great demo.
And one thing I wanted to kind of finalize on that is, I mean, like, it's very clear why I have you on here. I think for hopefully it's clear to everybody that we like why you're on here. Like LakeFS, you know, it's not like Trino community. A lot of times we're very focused on, like, you know, read performance and getting all that stuff right. But, you know, the data has to be right. And ultimately, a big part of the data engineer's job is to deal with ingestion, is to deal with all of these, you know, crummy little pieces of making all these other teams happy, and all the needs that they have. And I think LakeFS is going to be one of those pieces that, you know, really ease that burden so that, you know, nerds on the Trino world can all, you know, rejoice and be like, now I can just, you know, query and make my queries run super, super fast now. You know, you take away that pain. So I wanted to make make it clear why you're on here today. And that's because, you know, you're ultimately taking away that pain from a lot of these engineers. So.
Yeah, it definitely looks like a very interesting sort of like, you know, tool to have in your tool belt for those use cases where you want to separate different users into their own little realms, but stay on the same data. It's pretty cool. Very nice.
Yes. All right. Well, with that, on to the PR of the week. Again, I am not fast enough to share my screen. Bear with me.
Find that button.
It's because there's like 50 buttons to click on the way. I need to like draw out a longer intro music or something. Anyways, we're done with the demo of the week. Let's go talk a little bit about this week's PR of the week. It was done by one of the folks in the community named Patrick. So I thought this was a really, really neat PR. Because, you know, again, I'm all about the visuals, right? And so Patrick basically took one of these things that a lot of people complain about on our web UI, which is that you can't quickly determine what actually caused an error or an exception very easily without actually digging into a lot of the stack trace. And even sometimes the stack trace itself is like kind of missing some context. And we have these little like these error codes that are actually super, super informative. And we've just never thought to expose that until now. And so this was merged in the 362. So if you, whenever you get a chance to update 362, take a look at if you do have like a either a 500 or a 400 error that comes back, you know, definitely take a look at these little codes that you'll start to see up there. And they actually do, like, you know, so administratively preempted. That used to say something like I think, no, it just said external error. So it says external error still, but then it has this dash like, this is what the code is and how we categorize this. So this is, I think, traditionally just used for like counts, like how many of these do we have? But now we actually have this as part of the web UI so that you can actually see this. So I thought that was just, I don't know, to me, that just like quickly gets your mind into, oh, okay, this is the thing that caused it. I don't have to worry. This is a user initiated thing, or this is something in this particular area of the code. So I need to start thinking about where I should be focusing my time and attention on. And, you know, especially if prod's down or some, you know, you didn't have LakeFS, and so bad data got into there and you can't roll back. You know, you ultimately, you know, having these quick indicators of what to do is super, super useful. So thanks a lot, Patrick, for you know, putting this in. It's like small thing, but it's like super useful, right?
Yeah, Patrick has good insights because he helps users a lot. So he learns the pain points, and the web UI is definitely one of those super powerful tools that is geared a bit more towards expert users. So if you're not an expert user, getting these little helpers is super helpful. So thanks again. Yeah. It's good.
Yeah. And as quickly as we got onto the PR, let's get on to the question of the week. This time I'm ready. This time I just had to scroll down just a little. Okay. So this week's question of the week, I have a little link to it if you're on the Trino DB Slack. If you are not on Trino Slack yet, definitely join, and you can just click on this link for the question of the week in the show notes, and it'll take you to like a little sign up over there. But and then after that, it will take you to this question. But this comes from Marius. We had him on the show back at episode 20 to just discuss a little bit about being a Trinubi. He joined the Trino community roughly, I think, what is it, February, March timeframe?
Yeah, and remember, he just had another merge happening. He contributed the list aggregate function in 362, so he's very active, and so it's good.
Yeah, he ramped up super, super fast, and so we were really proud to have him in the community. But he's also very active on bringing up these really, really great questions that we need to do better at talking a little more about. And so he's working on DBT Trino. He already has a working DBT Trino adapter. But he wanted to kind of keep extending the functionality. And so he was looking at this, how do I implement this insert overwrite functionality? And this kind of ties back into some of the stuff I was trying to do for the demo, because I was trying to delete some of the data so that we could, essentially have the sandbox where you make the foul problem of just deleting way too much. So maybe if I had Paul, you have this thing called a bagel. What is it called? The full bagel?
The everything bagel.
Everything bagel. So there's a blog. I'll link this blog in the show notes as well. It's a much more fuller Docker Compose setup that has like Slack. It has a Spark and a couple other things. So if you wanted to do like deletes and things like that, that things that Trino is just like, here or there with, depending on the connector, basically you would be able to do this with Spark. But that's an aside. Insert overwrite, when it comes to RDBMS, Hive, Iceberg, really comes down to, and I actually didn't finish the notes here, but that's fine. What ultimately comes down to is, in Trino, the general thing I kind of like to get across to people that are expecting that Trino is going to replace everything is that Trino is primarily focused on, kind of these, what we would call like an OLAP use case. And, if I were to be very grossly oversimplistic, that means we kind of focus a lot more on reads and we focus a little less on writes. Now, there's a lot more that goes into it than just that, and there's even overlap in what OLTP is and OLAP is. But, if you were to generalize, there's, when it comes to it, like OLTP is transactions, you're talking about updates, you're talking about inserts, a lot of the stuff that, like LakeFS and Iceberg and a lot of these, Kafka, like they have a lot of these connectors that handle a lot of these like upsert type operations. And sorry, Spark, I meant to say Spark, not Kafka. And so they do a lot of these kind of more upsert operations. Now, Trino is slowly starting to pivot its head and try to integrate some of these. So, I don't want to say these are never going to be part of what Trino does, but in general, when you think about Trino, and one thing we typically like to, orient newcomers that are asking these types of questions, is like, why are the deletes so limited in Trino, or why can't we do these things? And we definitely can. We definitely probably will. The really thing that comes down to is what's the priorities. And so currently Trino typically sits, as an OLAP, once the data is in place, you read the data out and, is typically used by a BI tool or federated.
It's analytics, right? Like ultimately why Trino was created, it was to make analytics possible at a speed and performance that wasn't and still isn't possible with other tools, right? And that's where Trino shines and excels and kicks whatever,
Exactly.
So it's really, really good at that. And the write support is just something that because Trino has the connector concept and is very, very flexible, it also ends up having to deal with the differences, right? Like say, for example, in Hive, you can't just delete a little record because, well, the record is actually something that's hidden in a file, and the file is hidden in a directory, and you can't just like delete little bits in it. You would have to delete like the whole partition if it's a directory and that kind of stuff. So it gets more complicated. Versus others connectors, they can. So that's where we run into these edge cases. But there's definitely, like what you're saying, there's lots of stuff still coming on. So
yeah, I think, in general, what the kind of right type cases that you'll see Trino used for, if you are going to see one, is going to be like an append type thing where you're just copying data essentially, and you're not trying to do any type of transactional, insertion where you're or like, oh, this thing, these two rows match, so therefore this one gets overridden and I'll delete it and then I'll write in this new one. Like that's where Trino is. So explicitly decidedly
like the typical one that we showed it before now is the create table as, right, which is basically a copying operation. And we talked about update and stuff in one of our early episodes where David Stryker was on, who implemented update, right? And we're still working towards supporting SQL merge, stuff like that. So there's lots of stuff going on. So stay tuned on what happened there.
Totally. All right. Well, once again, Paul, thank you so much for joining us today. Like, really open up our eyes on, figuring out about LakeFS, and it was great having you.
Thank you so much for having me on. It was a lot of fun. I hope to make it back maybe one day on a future episode.
Totally. Yeah. When we get a couple more goodies to start demoing and playing around with, definitely we'll have you back on. And don't be a stranger for sure.
Excellent. Sounds good.
Cool. All right. Well, I'll see you all in 2 weeks.
Music for the show is from the Mega Man 6 gameplay album by Krzysztof Sławikowski. Don't forget to give us a star on the Trino repository at github.com/TrinoDB/Trino. And for more information on future shows and to find show notes, check out trino.io/broadcast.